With regard to the pharmaceutical industry and how the pharmaceutical industry has developed during my career, I've seen so many exciting drugs being brought forward by the industry. I've seen so many opportunities lost by the industry. But what I'm seeing today, I think, is a revolution in some of the thinking behind drug development with regard to new treatments for cancer. The gene editing technology, the CRISPR and other new advances in gene editing are revolutionizing or will revolutionize the treatments for many of the diseases that we're faced with today. Advances in immunotherapy are again going to have major impact on the treatment of diseases in the future. We're seeing imaging techniques now where we're looking at pathways in the brain for the first time in much greater detail than we've ever been able to, and also to excite those pathways by light with regard to how disease processes or pathophysiology may well play a part in these disorders. So my early days and the way pharmacology was basically we were using bioassays where we were using pieces of tissue, human, animal tissue, to evoke dose response curves with regard to various neurotransmitters. We were following that particular bioassay science into the brain, where we were measuring various aspects of neurotransmission, whether they be stimulated by drugs or by using microelectrodes. And all of these things we were building on with regard to trying to translate that work into the clinical situation, using EEG to look at brainwave patterns in the brain. The sophistication of that now compared to 30 or 40 years ago is just phenomenal. So those areas, PET imaging, it is now taking leaps and bounds from the first time the first radiochemical was labelled. So the level of sophistication and how we're opening up the brain now more to look inside using optogenics and all of these techniques is where the future lies in our science.